If we now want to determine the RMS value of this load voltage, then we can go back to the scientific definition of RMS, which is that it is the root of the mean, that's where this T comes in, of the square of the voltage. And due to symmetry of the waveform, we can only consider the positive half up to pi, from 0 up to pi, and therefore V load RMS is equal to, now the period here is from 0 up to pi, so T is pi, and the lower limit is 0 and the upper limit is pi, and the voltage is E, and it is squared and d omega t. And therefore, we can say the E does not change from 0 up to pi, so it's a constant, so it can come out of the special bracket formed by the integral sign and d omega t. So therefore, we have E squared over pi, and we have the integral of 1 d omega t, which is omega t, and the limits are 0 and pi. And therefore, we can say that it is the square root of E squared over pi, pi in the double variable, minus the 0 in the double variable. This pi goes into that pi once, and therefore we have the square root of E squared, which is E. From this we can see that the RMS value of a square wave is equal to the amplitude, square wave of amplitude E. The RMS value is the same as the DC value that we fed towards the load.